Right, moving on this series on how to program the MECB I/O card. So the next chip we're going to look at on the I/O card is the Programmable Timer module, and that's the MC6840 here. And this one actually proved to be quite a lot more tricky to program than I had hoped. And thanks to the help of two of the guys on the um, forum, between the three of us, we figured out how to, because there's not a lot of source code out there for 6502 source code for programming this timer chip. Anyhow, what's our objective here? Our objective here is to replace the loop I was timing with. I had a loop I was counting cycles in. We're going to replace that with just getting the timer to do the counting for us. So we still have the PIA ports to do the blinking of the LED. The LED is still there. We're just going to add the timer. And I've borrowed some code that I use in the Hopper runtime to do delays. Basically, there's 8 0-page addresses. 4 of them are used for the tick count. So the tick count is incremented in the IRQ handler. So here the tick count is incremented every time the timer fires. So to make this count in, say, milliseconds, that means we need the timer to fire once every millisecond. And then we have something called target 0 to 3, and that's used by the delay function. So all the delay function does is sits and waits in a loop until while ticks is less than or equal to target. It has to be less than, not less than or equal. It has to be less than, because you can't, without disabling interrupts here, which would not be good because you'd mess with the time, you can't atomically check all 4 bytes. So putting the less than and starting with the biggest one is a good way to see that we've hit our time. Don't lose too much sleep about it. And what I've done is I've made a 500 milliseconds delay by loading up 500 into the target. So this should, if we look at our program, we should delay twice. That should give us 1 second blinks. Turn it on, turn it off, like we learned in the previous one. And then the new thing here is init PTR. Init PTR, this is the thing that gave me a nightmare. That Emil and helped me figure out. He made some sample code that actually made this work. You program your timer 1 with, in my case, I'm running on a 4 megahertz clock, so 400 clock cycles would give us a 1 millisecond. And this is how you program the timer to be on a continuous running mode. And I also zero my tick count here when we initialize, so we start the ticks at 0. So it's so simple. It's like 4 instructions here, but you won't believe how much hair pulling this took. Anyway, similar to the PIA, not all 3 clocks on the PTM are the same, just like the 2 ports A and B are not exactly the same on the PIA. There's more functionality. I think clock 2 has more functionality in that it can have a divider on it. What do you call that? A prescaler. Yeah. Anyhow, and then how does the interrupt service routine work? It's very, very similar to like the ACIA interrupt service. What you do is when you in the beginning of your interrupt handler, you look at one of the registers. It's the status register, and you look at the top bit, which you can do by checking the minus flag, the negative flag, top bit. And if it is set, you go into your handler. So most the Western Design Center chips work this way, and most of the Motorola peripheral chips work this way as well. It's very convenient to check the top bit. Strictly speaking, we don't need to check the next bit because we've only got 1 timer. So if the timer fired an interrupt, it must be our timer. But it's just good manners to do this. And here we've got the status register in A. We rotate it to the right by 1. And the rightmost bit in the status register tells us that it was timer 1 that ticked. So if we rotate by 1, it goes into the carry flag. We can check against the carry flag. And then the way you reset the timer to start the next, to reload to relatch your to reset your time to start again is you just read the two latch registers and it'll reset. And then this is my incrementing the tick, and you can see with Hopper 6502 assembly, the syntax is very, very readable as to what this does. And again, I'll show you what the disassembly does and how small and convenient, it generates pretty good code. So let's F7 to assemble. And then let's see how big that was. So we can go 65, 65 DASM OG clean. And the file we want is PTM blink, I think. There we go. 165 bytes of code. Let's have a look at them. What's it called again? PTM blink dot listing. So this is what the disassembler produced. There's the main again. Here's the IRQ. So this is that increment of the 4 0-page addresses. It's pretty tight in terms of optimal code. And then this is the initialization. This is the delay where it's doing that less than the branch on carry clear to check that our target is matching our objective. Anyway, that's the code. So let's get that up into our EEPROM now. So we want PTM blink, and same as last time. And we verify that at the bottom we have our entry. And last time there was no IRQ handler. Now there is an IRQ handler. So let me show you how that works in Hopper 6502 assembly. Just like the main program in the entry point, which would be main in C, is called Hopper in Hopper 6502 assembly or in Hopper. The interrupt handler is just called IRQ. So if you make a function called IRQ, it'll automatically correctly give you you correctly program the vector over here. Okay, let's program that. I'm going to pause that and find out what's wrong, which I've got a pin skew in there, and then I'm going to start again once I've got it back in the device. All right, I've got it EEPROM back in the device, and we turn the power on. We should get some blinking. There we go. So there you go. You now know how to program the timer, at least one timer, and the others are very similar. And I must say thanks again to the guys on the Digicool Things forum for their support in helping me get this to work. All right, next and final I/O chip that we need to use is the serial port. So the ACIA chip is what we'll do in the next video. Thanks for watching.